Good morning, children.
Good morning, ma'am.
Good morning. Good morning, children. All right, so I don't remember seeing the answers to the questions I shared on WhatsApp. So let's see them now. So this was the first question. Find the distance between the points. Yeah, so last class, I think I gave you the introduction to the whole chapter. Yes. What did I miss out there? Oh, yeah, one more thing to discuss. 1 second, children. We didn't talk about, 3 points. We didn't talk about 3 and 4 points in a plane. Okay. So in continuation with the introduction, children. So last class we had the, a brief introduction to the whole chapter. I have 2 more things to share with you. So let's now talk about, 3 points or 4 points lying on a plane. Or we'll see the figure formed, if any. Okay, we'll see the figure formed, the plane figure formed, if any, when we have 3 points or 4 points lying on a plane. All right. So now let's consider 3 points. Now let's consider 3 points. See, when you have 2 points in a plane, when you have 1 point, it's only a point. On a plane, when you have 1 point, it's just a point. You can, name it by any capital letter, like say point A. Now, when you have 2 points in a plane, we know that 2 points can always be connected by the same straight line. That's all, nothing much. When we have 2 points on a plane, we know that there is one and only one line joining these 2 points. That's all, nothing else, nothing more. Now, when we have 3 points on a plane, so here 2 cases arise. When the 3 points are collinear, when the 3 points are not collinear. When the 3 points are collinear, when there are 3 points in a plane and the 3 points are collinear, they can be connected by the same straight line. They can be connected by the same straight line. That is, if the points are say A, B, and C, we can prove that if AB plus BC, that is, you should find the length of AB using the distance formula. You must find the length of BC using the distance formula. If the length of the line segment AB plus the length of the line segment BC is equal to the length of the line segment AC, then this is the check for collinearity. Then the 3 points are collinear. Then the 3 points are collinear. I'll come again. So we have 3 points on a plane. The 3 points can be connected by the same straight line, which means the 3 points are collinear. Let's call the points P, Q, and R. Let's use the distance formula to find the length of the line segment PQ, the length of the line segment QR, and the length of the line segment PR. So the check for collinearity is this. If PQ plus QR is equal to PR, you see, you need to find PQ separately, QR separately, and PR separately. So let me put it in general like this. So if the sum of any 2 line segments, so say this is 7 units and this is 3 units, not with respect to this figure, I'm just saying in general, okay, not with respect to this figure. And if PQ is say 10 units, so you see that 7 plus 3 is equal to 10. You see that 7 plus 3 is equal to 10. Let me take out this figure. Okay. Because otherwise, when the points are given, you will not know which point lies between the 2 other points. So, yeah. So supposing PQ is 10 units, you work PQ and you find it's 10 units. You work QR and you find it's 7 units. PR is, 3 units. So what do you observe? You see that QR plus PR is clearly equal to PQ. QR plus PR is equal to PQ. R is repeated. That means R lies between P and Q. That means R lies between P and Q. You can put P here and Q here, or you can put Q here and P here. Okay. R is repeated. QR, PR, R is repeated. That means R lies between does not mean midpoint. Between. does not mean midpoint. Midpoint is midpoint. Between means not midpoint. So since R is repeated, R lies between the points P and Q. So it can be P here and Q here, or P here and Q here. Another example, supposing AB is 7√3 units. BC is 13√3 and AC is 6√3. Okay. So what do we observe here? AB plus AC. AB plus AC. We will find AB plus AC, and that is 13√3 units. BC is also 13√3 units. So since AB plus AC is equal to BC, AB plus AC is equal to BC, we conclude that the 3 points are collinear. The 3 points are collinear. So now A is repeated. A is repeated. That means the endpoints are B and C. The endpoints are B and C. And A lies between B and C. I repeat, C. A need not be the midpoint of BC. A lies between B and C. So it can be B here. See, A is repeated. A is repeated. So A lies between B and C. It can be B here, C here, or it can be B here and C here. So if the sum of, any two line segments is equal to the length of the third line segment, that means the 3 points are collinear. The 3 points are collinear. Now, you'll be wondering, how can this be a check for collinearity? I'll tell you why. Because, AB plus, that is the, let me take. Now we know that when a triangle is formed, okay, I think that should come after this one, children. I'll tell you why. I'll tell you why AB. We found the sum of two line segments, and when it's equal to the third one, we said that the 3 points are collinear. I'll tell you why that's a check for collinearity. Let me finish this. Now, when the 3 points are not collinear, okay. So when they're not collinear, so probably something like this. All right. So now you know that 2 points can always be connected by a straight line. 2 points are all, see, collinearity, the term collinearity does not apply to 2 points. 2 points always can be connected by the same straight line. So the term collinearity is used for 3 or more than 3 points. The term collinearity is used for 3 or more than 3 points. 2 points always can be connected by the same straight line. So when we have 3 points in a plane, and the 3 points are not collinear, then a triangle is formed. So you can see here a triangle is formed. So that's the definition of a triangle. To form a triangle, you need 3 points in a plane. To form a triangle, you need 3 points in a plane. And the points must not be collinear. The 3 points must not be collinear. If you have 3 points in a plane and the 3 points are not collinear, then a triangle is formed. Now we know that, in a triangle, if I call this triangle ABC, we know that in a triangle, the sum of any two sides is always greater than the third side. In a triangle, the sum of any two sides is always greater than the third side. So AB plus AC will always be greater than BC. It will not be equal to. If it is equal, the points are collinear. If it's greater than, so if it's like this, a triangle is formed. We know that in a triangle, we have learned this. In a triangle, the sum of any two sides is always greater than the third side. The sum of any two sides is always greater than the third side. So when the 3 points are not collinear, that means a triangle is formed. So there you will see that AB plus AC will be greater than BC. AC plus BC will be greater than AB, and BC plus AB will be greater than AC. The sum of any two line segments will always be greater than the third one. Now, there are only two possibilities. When we have 3 points in a plane, there are only two possibilities. Either the 3 points are collinear. See, you cannot think of anything else. Now, don't say I'm going to mark all the 3 points one over the other. See, we're not talking about all this. So I'm marking all the 3 points one over the other. No, we're talking about 3 different points, 3 distinct points. We're talking about 3 distinct points, not about points that lie one over the other. So when we have 3 distinct points in a plane, only 2 things are possible. Either the 3 points are collinear, or if they are not collinear, a triangle is formed. Nothing else can happen. When there are 3 points in a plane, 3 distinct points in a plane, only 2 things can happen. Either the 3 points are collinear, that means no triangle is formed. When the 3 points are collinear, no triangle is formed. So we know that to form a triangle, we need 3 points on a plane. We have 3 points. But since the 3 points are collinear, no triangle is formed. If the 3 points are not collinear, then a triangle is formed. If they are not collinear, a triangle is formed. If they are collinear, no triangle is formed. Area of the triangle is 0. All right, children. So when a triangle is formed, we know that the sum of any 2 sides is always greater than the third side. And this situation is ruled out. Because when these are the only 2 things possible, there cannot be a case where the sum of 2 line segments is less than the third one. The sum of any 2 line segments cannot be less than the third one. In case of collinearity, the sum of this, the length of this line segment and this one will be equal to the third one. In case of collinearity, the sum of these 2 line segments will be equal to this one. That is when the 3 points are collinear. If the 3 points are not collinear, a triangle is formed, where the sum of any 2 sides will be greater than the third side. That's why when the sum of any 2 lengths is equal to the third one, no triangle is formed. Because if it's a triangle, the sum of any 2 sides will be greater than the third side. It cannot be equal to. Now you will wonder, what if there are 3 points and the sum of like the sum of this side and this side is equal to this side. The sum of this side and this side is equal to this side. That is, the sum of 2 line segments is equal to the third one. No, the triangle cannot be formed like that. We know if a triangle is formed, the sum of any 2 line segments will always be greater than the third one. If it's a triangle, the sum of any 2 line segments will always be greater than the third line segment. So when AB plus BC is equal to AC, no triangle is formed. No triangle is formed because this is not possible. If it's a triangle, the sum of 2 sides cannot be equal to the third side. Is always greater than the third side. So no triangle is formed here. Then the points have to be collinear because they're the only 2 things that can happen with 3 points. Because they're the only 2 things that can happen with 3 points. Either they're collinear or a triangle is formed. But if a triangle is formed, the sum of any 2 sides will be greater than the third side, or the sum of any 2 line segments will be greater than the third one. But here it's equal. So what is the other thing available? They have to be collinear. So that's why there's a check for collinearity. Since you do not have area of triangle, that's removed from your syllabus for this year. We can also do using that formula, the formula to find the area of a triangle, but we'll not do that because it's not a part of your syllabus this year. Yeah, so this is about 3 points in a plane. So when we have 3 points in a plane, either they're collinear or a triangle is formed. Okay, now when we have 4 points in a plane, when we have 4 points in a plane, they can be collinear like this. All the 4 points can be collinear. Why are we talking about 4 points? Because we need 4 points to form a quadrilateral. But simply if you have 4 points on a plane, you cannot get a quadrilateral. You cannot make a quadrilateral just by having 4 points in a plane. The 4 points in a plane must cater to a condition, must satisfy a particular condition. Only then a quadrilateral is formed. All right. So we'll take up one by one. The first case where the 4 points are collinear, then no quadrilateral is formed. When the 4 points are collinear, no quadrilateral is formed. Now, the second case, we'll just move 1 point away. We'll put 3 points like this and we'll move 1 point away. All right. Let's see if a quadrilateral is formed. No, these 3 points are collinear. Oh no, though we have 4 points, we are only able to make a triangle out of this. Though we have 4 points, we are only able to make a triangle out of this. Because 3 points are collinear. Because 3 points, we have 4 points. And we think we can make a quadrilateral using these 4 points. But what happens? 3 points are collinear. So only a triangle is formed. Though we have 4 points, by joining them, we are able to make only a triangle, form only a triangle. Okay. So now, so here, what was the problem? The problem was because 3 points are collinear. 3 points are collinear. So no triangle, no quadrilateral is formed. You can only form a triangle. Now we'll do one thing. See, what was the first case? All the 4 points were collinear. Then we moved 1 point away. We had 3 points like this and we moved 1 point away, the 4th point away. Now we'll move 2 points. We'll move 2 points. First all the 4 points were collinear. Then from the 4 points, 1 point we moved it away. Now we'll keep 2 points like this and move the 2 other points. 2 other points. You place it wherever you want, like here and here, wherever. All right. Now we'll join. I will join. See, you have to join in order. This is not a Rangoli, making. So you have to join in order. You cannot just join as, we please. So like this. So you see that when we have 4 points in a plane, of which no 3 points are collinear, a quadrilateral is formed. So it is not enough if we have 4 points in a plane. When we have 4 points in a plane, the 4 points can be collinear. The 4 points can be collinear, the first case. So you only get a line segment. No plane figure is formed. Neither a triangle nor a quadrilateral. No plane figure is formed. Then second case, we moved 1 point away. We had 3 points as it is. We moved the 4th point away. And then when we try to connect the points, we were only able to form a triangle. Because 3 points were collinear. 3 points were collinear. We were only able to make a triangle. Then what we did in the next case, we moved 2 points away. We moved 2 points away. Then when we joined the points in order, we were able to form a triangle. So a quadrilateral, when we were able to form a quadrilateral. The third case, when we moved 2 points away, we were able to form a quadrilateral. So a quadrilateral is a figure formed by joining 4 points in order, of which no 3 points are collinear. A quadrilateral is formed by joining 4 points in order, of which no 3 points are collinear. So this is a check, meaning when you have 4 points, and you're asked to check if a quadrilateral is formed. This is what we'll be using. What will we be using? So when you find, supposing the points are A, B, C, D, A, B, C, and D. Supposing you're given A, you're given B, you're given C and D. And the question is, do the points A, B, C, and D form a quadrilateral? So what should we do? So you should find AB. You should find the length of all possible line segments. You must find the lengths of all possible line segments. Okay, so you should find AB, find the length of AB. That is the 4 sides and the 2 diagonals, children. You must find the, we'll take up a question so you'll understand better. You should find the length of all the possible line segments. That is, assuming that ABCD is formed, a quadrilateral. What can you find? AB, BC, CD, AD, and the 2 diagonals. Assuming a quadrilateral is formed, you can find the diagonals AC and BD. So find the lengths of all these 6 line segments using the distance formula. Find the lengths of all these 6 line segments using the distance formula. And then if you find that the sum of any two line segments is equal to the third one, if you find that, so now you have 6 lengths with you. You have 6 lengths with you. Now, of these 6 lengths, if you find that the sum of any two lengths is equal to the third one, the sum of any two lengths is equal to the third one, that means those 3 points are collinear. That means those 3 points are collinear. Now, for example, if this is B, this is D, this is A, and this C here. Okay, you will find that BD plus DA in your working, you will find that BD plus DA is equal to BA. You will find that BD plus DA, if supposing the arrangement of the 4 points is like this, if the arrangement of the 4 points is like this, so we have not plotted these points on a graph, right? When you plot these points on a graph, you can easily make out. You can plot these points on a graph, and you can easily make out if a quadrilateral is formed or not. But ours is this is algebraic way of finding. Okay, you have to work not by plotting. We have to work algebraically and then comment if a quadrilateral is formed or not. So supposing you find that BD plus DA is equal to BA, then the figure will be something like this. That means no quadrilateral is formed because 3 points are collinear. How do you know that 3 points are collinear? Because from the working, we are able to find out that BD plus DA is equal to BA. So from this, we understand that the points B, D, and A are collinear. So of the 4 points, if 3 points are collinear, no quadrilateral is formed. Only a triangle is formed. Supposing we are given the points P, Q, R, and S. So we believe a quadrilateral PQRS is formed. And we find PQ, we find QR, we find RS, we find PS, and we find the diagonals, assuming PR and QS. And supposing you find that and supposing from the working, you're able to find out that PR plus RQ is equal to PQ. PR plus RQ is equal to PQ. That means the points P, R, and Q are collinear because PR plus RQ is equal to PQ from your working, which means R lies between P and Q. See here, R is repeated. R is repeated. So that means R lies between P and Q. R lies between P and Q. So here P, Q, R lies between P and Q. So S is away. S is away. S is away. So it's like this. So though you have 4 points in a plane, a quadrilateral is not formed because 3 points are collinear. What's the definition? A quadrilateral is a figure formed by joining 4 points in order of which no 3 points are collinear. But here 3 points are collinear, so no quadrilateral is formed. You can only make a triangle. So now how do you make out that a quadrilateral is formed? How do you make out? Okay, this is the case where we have 4 points. This is the case where we have 4 points, but no quadrilateral is formed. Only a triangle is formed. See, we don't have to say if a triangle is formed or not. No quadrilateral is formed. The points P, Q, R, and S do not form a quadrilateral. That's all. You don't have to write that they form a triangle. Since 3 points are collinear, how do you conclude after working all this? What is the conclusion? Since the points P, how do you know that the points P, R, and Q are collinear? Because PR plus RQ is equal to PQ. So the points P, R, and Q are collinear. So the conclusion is the points P, Q, R, and S do not form a quadrilateral because the points P, R, and Q are collinear. Now, if a quadrilateral is formed, how do you know a quadrilateral is formed? If a quadrilateral is formed, for us, in our syllabus, we will always have at least one pair of opposite sides equal. If a quadrilateral is formed in our syllabus. Okay, so if a quadrilateral is formed, at least one pair of opposite sides, both the pairs, actually for you, both the pairs of opposite sides will be equal. Both pairs, now supposing the quadrilateral is ABCD, you will see that the sides are AB, BC, CD and AD. You will see that AB is equal to CD and BC is equal to AD. So opposite sides are equal. It's a parallelogram. Opposite sides are equal. When opposite sides are equal, it can be a parallelogram or a rectangle. But for us, we don't have to prove it's a parallelogram or a rectangle. When opposite sides are equal, that means a quadrilateral is formed. It may be a parallelogram, which is a quadrilateral. It may be a rectangle, which is a quadrilateral, but a quadrilateral is formed. So you will only get the situation. So when you find AB, BC, CD, and AD, you will see that the opposite sides are equal. AB is equal to CD and BC is equal to AD. So a quadrilateral is formed. It's a rectangle. It's a parallelogram. In general, it's a parallelogram. It may be a rectangle. Okay, so what we discussed now is about 3 points and 4 points in a plane. When we have 3 points in a plane, there are 2 cases. The 3 points can be collinear or not collinear. If they are collinear, no triangle is formed. If they are not collinear, a triangle is formed. When there are 3 points in a plane, there are only 2 things that can happen. Either the 3 points are collinear. So you can just join them by a line segment. No triangle is formed. But if the 3 points are not collinear, you can join them in order and form a triangle. When we have 4 points in a plane, and if they are collinear, so 4 points we need to form a quadrilateral. 3 points we need to form a triangle because 3 vertices, so 3 points. 4 vertices, so 4 points. So when we have 4 points in a plane and they are collinear, no quadrilateral is formed. Supposing 3 points are collinear. Now first 4 points are collinear, no quadrilateral is formed. Now 3 points are collinear. When 3 points are collinear also, no quadrilateral is formed. You can only make a triangle. So when is a quadrilateral formed? So a quadrilateral is formed by joining 4 points in order, of which no 3 points are collinear. No 3 points must be collinear. If 3 points are collinear, no quadrilateral is formed. All right, children. So yeah, you can take a screenshot of this one. This is the answer to the question which I posted. So to tell you in simple words, we understood that the distance formula works like this. These are the x coordinates. These are the x coordinates. Write them in any order. See, you can write a plus b first or a minus b first. See, this is the x coordinate of p. This is the x coordinate of q. Write anything first. Subtract them and find their square it. Plus, this is the y coordinate of p. This is the y coordinate of q. Y coordinate of q. Actually, you can write them in any order. You can write them in any order. So write them in any order. You need to subtract them and square it. So square root of difference between abscissa, the whole square, plus difference between the ordinates, that is the y coordinates, the ordinates, the whole square. So please feel very comfortable while substituting the points. Don't mind about the order. I've been telling this so many times. Just these are the x coordinates. Write them in any order. See, but you should subtract them. So if there is more than one term, put them in, enclose them in a bracket. See, there's a plus b, a minus b. So I've enclosed a plus b and a minus b in a bracket because there's more than one term. So enclose them in a bracket. You can write anybody first, enclose them in a bracket, subtract and square, plus y coordinates, any order, anybody first, subtract, square. And then, a plus b comes as it is. And this is the whole, it's not a minus b square here, children. It's the whole square. So you can open the brackets. You can open the brackets because it is not square here. It's the whole square. So you can simplify the brackets and then you'll have to square it. So a plus b minus a plus b. minus a plus b the whole square. This is b plus c minus c plus b whole square. So what happens here? A. Yeah, somebody wants to say something?
Ma'am, I have a doubt, ma'am.
Yeah, tell me.
Ma'am, can we do x minus y plus y minus x the whole square?
Right. Yes. Yes, yes. You can write. You can write, that is, your question is, can you write c minus b plus c here, right? Correct?
Yes, ma'am.
You can do it. You can do it.
Ma'am,
Without
first we wrote x minus y. Here, can we change it to y minus x also, ma'am?
First, we didn't write x minus y. We wrote x minus x only. We are subtracting the x coordinates, subtracting the y coordinates, not x minus y.
Yes, ma'am. No, ma'am.
I get your question. See, okay, you tell me. You don't ask your doubt. You tell me, how do you want to write it? Tell me. You want to write it in a different order, no? Tell me. I'll tell you if you're right or wrong.
Ma'am, a plus b minus a minus b the whole square.
Okay, then what do you want to write? Plus
c minus b minus b plus c the whole square.
perfect. 100 out of 100. You can do that.
Okay, ma'am.
Yeah. So a gets a minus a gets cancelled. So b plus b is 2b, 2b the whole square. Here plus c minus c cancels. B plus b is 2b, the whole square, the square, whole square. So now this is 4b because it's 2b into 2b. 2b into 2b is 4b square. And again, 2b into 2b is 4b square, 4b square. So 8b square. 8b square. Now you can see this step. I've worked it like this. You can write the answer directly also. 8 root of 8b square, which is 2 root 2b units. Because what is root 8 to root 2? What is root 8, children? Root 8 is 2 root 2. Root 8 is 2 root 2. And b square will come out as b units. You can just write it like this. You need not give this step also. You can write it as 2 root 2b, children. 2 root 2b units. Is it fine? Yes or no, children? Yeah. So I said after this, you can directly write 2 root 2 because root 8 is 2 root 2 b units. You need not show this. All right, children. Yeah, I think I also gave you this one. So here, see here, difference between the x coordinates, the whole square. Difference between the x coordinates, the whole square. So see here, I've written this one first. A sine alpha. Difference, right? So minus a cos alpha. So minus into minus is plus. Plus a cos alpha, the whole square. See, you'll have to subtract these two. You'll have to subtract these two. So what is it actually like? It will be a sine alpha minus a cos alpha, the whole square. So minus into minus is plus. Minus into minus is plus. So you can see here. Okay, let me write that step so that all of you. So AB is equal to square root of a sine alpha minus a cos alpha, the whole square. Difference between the x coordinates. Difference between the x coordinates, the whole square. Then plus difference between the y coordinates. I've written b sine alpha first. I've written b sine alpha. It's very nasty. Just write it neatly, children. Sorry. Oh my God. This can be your first step. Square bracket, simple bracket. My God, why am I making so many mistakes? 1 second. square bracket a sine alpha minus a cos alpha the whole square plus square bracket b sine alpha minus b cos alpha, close the bracket, like this. This is the first step. AB is equal to, please watch this. Difference between the x coordinates. Difference, so I've written the two x coordinates and there's a minus sign in the middle. Difference between the x coordinates, the whole square, plus difference between the y coordinates, the whole square. So I've written this one first and then this. See here, a sine alpha and then minus a cos alpha. Difference, or minus whole square, plus I've written now in the second part, I've written this one first, b sine alpha first, and then I've written minus b cos alpha, minus b cos alpha. You can see the minus here. So this is the y coordinate of b. This is the y coordinate of a. Subtract. And that will give you minus into minus plus, minus into minus plus. So a sine alpha plus a cos alpha the whole square plus b sine alpha plus b cos alpha the whole square. So now inside the bracket, you can see that a is common. Inside the bracket, you can see that a is common. So I've taken out a common. While doing this, children, you'll have to be very careful. See, when you take out a common, the square applies for a also. The square applies for a also. See, when you take out, see, a sine alpha plus a cos alpha, the whole square. Okay, so when you take out a common, the square applies for a also. So we write that very carefully. See here, I've taken out a common. When you take out a common, it looks like this. A into sine alpha plus a into cos alpha, like this. The whole thing is squared. The whole thing is squared. Be careful there. Here also, when you take b common, when you take out b common here, children, b common, b sine alpha plus b cos alpha. The whole square, see the square, the whole square. Because the square is for the whole thing. So now write the square separately. A square, because it's the whole square, it is a square plus sine, it is a square into sine alpha plus cos alpha the whole square. Here it will become b. See, like when you have a into b plus c the whole square. If you have a into b plus c the whole square, a into b plus c the whole square, it is nothing but a square into b plus c the whole square. You'll have to apply the square for, all the terms and not all the terms, like you understand everything inside the bracket. So it's like a into b plus c, a into b plus c. So that will be a square into b plus c the whole square. Similarly here, a square into sine alpha plus cos alpha the whole square. Applying the square for b and for a and sine alpha plus cos alpha. 1 second, children, just a second. Yeah, so here also b square into sine alpha plus cos alpha the whole square. Now you can see that this is common. Sine alpha cos alpha the whole square. Sine alpha cos alpha the whole square is common. So sine alpha plus cos alpha the whole square is common. So in the bracket you would get a square plus b square. In the bracket you will get a square plus b square. A square plus b square. Now, why do you want to, don't disturb the square. Now, don't think a plus b the whole square is a square plus 2ab plus b square. Why do you want to do that? The terms are under the square root. You want to get rid of the square root. You want to bring your terms out of the square root. So you should be happy when you have a plus b the whole square under the square root. Don't expand it. You can get rid of the square root, because when it is sine alpha plus cos alpha the whole square, so it comes out of the square root as sine alpha plus cos alpha. Don't expand it. The terms are under the square root. You want to get rid of the square root symbol. So when they are perfect squares, have them as it is. Don't expand and disturb them. So sine alpha plus cos alpha the whole square will come out of the square root as sine alpha plus cos alpha. But this remains under the square root of a square plus b square. Root of a square plus b square units. Yes, children, you can ask me if you have any questions. Okay. So A is equidistant from B and C. A is equidistant from B and C. A is equidistant from B and C. That means AB is equal to AC. AB is equal to AC. So if AB is equal to AC, AB and AC, when you use the distance formula, they'll have square root on both the sides, right? AB, when you write AB, when you write that using the distance formula, you'll have square root on both the sides. So when you square, AB square is equal to AC square, you should write it without the square root, that's all. So here AB is equal to AC. So when you apply the distance formula, you will get square root of x2 minus x1 the whole square and all that is equal to square root of, all right. So to avoid all that, what you can do, you can square this. So if AB is equal to AC, AB square is equal to AC square. So that means you write the formula, but without the square root. Because when you square root, the square root is eliminated. Like when you have root 5 and you square it, it's just 5. It's just 5. So now the formula is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now when you say AB square, AB you will write this. When it's AB square, you're squaring it, right? So when you square it, what happens? The square root is eliminated. The square root is eliminated. That's all. So AB is equal to AC. That means AB square is equal to AC square. So on both the sides, apply the distance formula, but don't put the square root symbol. The square root symbol you don't have to put because it's AB square. AB will have the square root. AB square, when you square it, the square root is eliminated. Okay. But that's not the distance formula, children. Don't think you can also write the distance formula without the square root symbol. No, no. When you're finding only AB, don't think you can find AB square. If you find AB square also, next you should find AB is equal to square root of. Supposing you find AB square is equal to some 8 units you get. AB square is 8 units. What is AB? AB is equal to square root of 8 units. When it is simply only one line segment AB, don't square it. You will apply it using this. Now, since it's an equation, you can square on both the sides because it's an equation. AB is equal to AC. It's a condition. AB is equal to AC. You square on both the sides, you will get AB square is equal to AC square. So you can write the formula without the square root symbol. So you can see here, AB is equal to so see here, when it is AB square, you should use the points. You must use the coordinates of A and B. AB square, you should use the coordinates of A and B. So I've written this one first. A plus B minus X, the whole square, plus B minus A minus Y, the whole square. You'll have to write AB square, right? AB square. So you should use the coordinates of A and B. So subtract the X coordinates. A plus B minus X, the whole square. B minus A minus Y, the whole square. Then for AC is equal to AC square. For that, A minus B minus X, the whole square, plus A plus B minus Y, the whole square. Okay. Now to proceed, children, what you do is, I told you this, what you do, now this one has A, B and X. This one has A, B and Y. Here also A, B, X, A, B, Y. See, if you have to expand this, you'll have to use the formula X plus Y plus Z. The whole square is equal to X square plus Y square plus Z square plus 2XY plus 2YZ plus 2xz. You can do that. You can use this formula and expand. You'll have to expand all these. See, this is x plus y plus z the whole square, x plus y plus z the whole square. There are 3 terms. You'll have to square these 3 terms. So they come into this formula. X plus y plus z the whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. That's going to be a little time consuming. You can do that. What I have done is this has a, b, and x. On the other side, this one has a, b, and x. So I've transposed. I've taken this to the LHS. So that comes to the LHS as minus a minus b minus x the whole square. Then this is a plus b minus y, which is in the RHS. I've taken this one to the RHS as minus b minus a minus y the whole square. So now what happens? What happens when you do this? Now this is a difference of 2 squares. This one is also a difference of 2 squares, like x square minus y square. Okay, they look like x square minus y square. This is x square minus y square. What is x square minus y square? X plus y into x minus y. What is x square minus y square? X plus y into x minus y. So see here, this is x. Write this as it is, x. Write this. Plus y. So when it's plus y, these terms will come as it is. Then into x minus y. This is x. This is x minus y. That means the signs will change. Minus y. So this will be minus a plus b plus x. Minus a plus b plus x. And on the other side, again, the same formula. X square minus y square. This is x square minus this is y square. This full thing is x square minus this full thing is y square. What is x square minus y square? X plus y. So you can see this one, x. You can see it here. A plus b minus y. X plus y. Plus y, so the terms will come as they are, meaning with the same signs. Plus b minus a minus y. Into a minus b. A minus b. So this is a. Oh, sorry, x minus y. So a plus b minus y. A plus b minus y. X minus y. Change the signs. Minus b plus a plus y. Minus b plus a plus y. Because a minus b or x minus y. That's all. You're done. Now what happens? Plus b minus b. So we have 2a minus 2x. Minus 2x. 2a minus 2x. Here a minus a. Minus x plus x. B and b is 2b. So similarly here, a minus a plus a. So this is 2b minus 2y. Out here, so 2a. 2a. Yeah. Now there's 2 common here. There's 2 common here. So I brought out that common factor 2. 2 into a minus x. And here also 2 common. So 2 into b minus y. Then you're multiplying. Then you're actually, so this is 2 into a minus x into 2b. So 2 into 2b is 4b into a minus x. 2 into 2a is 4a into b minus y. 2 into 2a is 4a into b minus y. So now on either sides we have 4. 4 and 4 on either sides gets cancelled. 4 and 4 on either sides gets cancelled. So you're left with b into a minus x. So b into a is ab. B into minus x is minus bx. 4 cancels, right? So a into b is ab. A into minus y is minus ay. Now ab on both the sides gets cancelled. Ab on either sides gets cancelled. So we have minus bx is equal to minus ay or bx is equal to ay. That's what we had to prove. Prove that bx is equal to ay. So remember this transposing, that saves time. When you do this, you save time. Otherwise, you will get 6 terms here, 6 terms here, 6 terms here, 6 terms here. So 12 terms here, 12 terms here. It will take a longer time. It's not difficult. It will take a longer time. So you can transpose like this so that, they look like difference of 2 squares. And you can use the formula x square minus y square is equal to x plus y into x minus y. Yeah, so these three answers, I shared the questions the other day. I hope you've taken a screenshot. Please complete them. I'll show you again. This is the first one. Please work this in your book. This is the second one. This is the third one. All right. I'll just come back, children, just a minute. Yes, children. Yeah. Find a relation between x and y such that P of x comma y is equidistant from Q and R. So similar to what we just saw, it's given that P is equidistant from Q and R. P so P is equidistant from Q and R, is equidistant from Q and R, Q3, 6, R minus 3, 4. All right. So PQ is equal to PR. That's the meaning. If P is equidistant from Q and R, that means PQ is equal to QR, or PQ square is equal to QR square. So that's all. Use the distance formula, and you will get an equation in X and Y. And that is the required relation. So see here. So P is equidistant from Q and R. So that means you can draw this figure like this, children. P here, Q and R here. So PQ is equal to PR, or PQ square is equal to PR square. So then you know how to substitute all this. And again, there's x minus 3 here. there is x in 3 here. There's meaning there's x here and there's x here. So I've transposed this one. So this comes x plus 3 the whole square to the left hand side as minus x plus 3 the whole square. And here this y on the right hand side, we have y minus 4 the whole square. I've transposed this one. So that you can, work it as a difference of 2 squares. You can also expand. See, this is just an option. You can also expand using the formula a plus b the whole square, a minus b the whole square. You can do that. I have just transposed so that, I can use the identity a square minus b square is a plus b into a minus b. So you can see here a plus b into a minus b. And this is also like a square minus b square. So a plus b into a minus b. Any questions here, children? You must ask me. I'm transposing. And see, there's a plus sign here. So when you transpose, so when you bring there's an x here, so you can bring this here. And there's y here, so you can just take this here. When you do that, this can be treated as a difference of 2 squares, a square minus b square. This also a square minus b square. So a plus b into a minus b. When you write a minus b, whatever terms are there in b, write them with the opposite sign because a minus b. So whatever terms are there in b, write it with their opposite signs. A plus b into a minus b. And then, yeah, rest of it you can follow. Cancel this 2 and 2 here. 2 on either side gets cancelled. 2 and 2. So minus 6x, minus 6x. And here 2 is common. So 2 into y minus 5. 2 is common here. So 2 into y minus 5. Again, you can cancel. 2 ones are 2 minus 3 times. So minus 3x is equal to y minus 5. Or if you take this one here, 3x plus y minus 5 is equal to 0. That's the required relation between x and y. That's the required relation between x and y. See here, x and y are connected in an equation here. So this is the required relation between x and y. 3 times x plus y minus 5 will be 0. 3 times x plus 3 times x plus y minus 5 will be equal to 0 is the required relation between x and y. Two gets cancelled on either sides. Minus 6x, and then I've taken 2 common here. So 2 ones are 2 minus 3 times. So minus 3x is equal to y minus 5. Then when you transpose 3x plus y minus 5 is equal to 0. So whenever the term equidistant is used, P is equidistant from Q and R does not mean that P is the midpoint of QR. P is equidistant from Q and R does not mean P is the midpoint of QR. No, PQ is equal to PR. PQ is equal to PR. That's the condition. So when you square, you get PQ square is equal to PR square. So this is PQ square is equal to, this is PR square. We are working with that condition. The condition is this. So this is PQ square and this is equal to, this is PR square. All right, children. Class, use the emoji. Raise your hand. Tarun, Murali, Ram, Raja Rajeshwari, Priyanka, Ananya, Harini, Sneha, Murali, Krishna. Very good. All right, children. Just a second, children. Children, just take a screenshot. We have just 15 more minutes, so I don't want to, give you time to write and, wait. So just take a screenshot. It's a holiday today. Maybe you'll have time to complete it. Take a picture. Yeah. So here, if a point A is equidistant from the points B and C, then find the value of P. So for all this, the same is the condition. The condition is the same. What is the condition? It's given that A is equidistant from B and C. It's given that A is equidistant from B and C. That means AB is equal to AC, or AB square is equal to AC square. That's all. A is equidistant from B and C. That means AB is equal to AC. That's it. Just write this condition, use the formula, and you will get the value of P. So see here. A is equidistant from B and C. That means AB is equal to AC. AB is equal to AC, or AB square is equal to AC square. AB is equal to AC, or AB square is equal to AC. You can write that AB is equal to AC, or AB square is equal to AC square. So how do you write AB square? Using the points A and B. And how do you write AC square? Using the points A and C. You know, difference between the x coordinates whole square plus difference between the y coordinates whole square. You can subtract in any order. Any order. So the condition is AB is equal to AC. On squaring, you get AB square is equal to AC square. So use the distance formula. Yeah, this is simple. 3 minus 0. So 3 square, 9. P minus 2 the whole square. This is P. You can expand it here. You can expand this. And this one is P minus 0, which is P. So P square. And this is 5 minus 2, 3. 3 square, which is 9. 3 square, which is 9. You could have expanded it in this step itself, children. You don't have to write P minus 2 the whole square as it is. Expand it. Yeah, and then on simplifying, if your P square minus P square gets cancelled on both the sides. So on working, you find P is 1. Very simple. Equidistant is not midpoint. A is equidistant from B and C. That means AB is equal to AC. That's all. That's the condition. AB is equal to AC. So AB is equal to AC means AB square is equal to AC square. So how do you write AB square? Using the points A and B. AC square using the points A and C. That's it. Work and find the value of P. Take a screenshot, children. Please take a picture. Find the equation of the perpendicular bisector of the line segment joining the points A and B. Also find its point of intersection with the x-axis and y-axis. Now we need to first understand the question. I don't understand what the question is. Find the equation, okay, of the perpendicular bisector. Oh yeah, perpendicular bisector is a line. So if it's a line, it has an equation. It's given by a linear equation in x and y, correct? Find the equation of the perpendicular bisector. Perpendicular bisector is a line. So if it's a line, it's a straight line. If it's a straight line, yeah, we know that it is given by a linear equation in x and y. That is what is that equation? Find the equation of the perpendicular bisector. So perpendicular bisector of a line segment, right? This perpendicular bisector bisects a line segment. So of the line segment joining the points A and B. So the 2 points are A and B. And the join of AB, when you join A and B, you get the line segment AB. When you join the points A and B, you get the line segment AB. And the perpendicular bisector. Okay. So perpendicular bisector, you need to find the equation of that perpendicular bisector. See, I'll just show you on a graph how it look on a graph paper. All of you, please listen carefully. 7, 1. 7 somewhere here. Okay, 7, 1 here. 7, 1. 3, 5. 3 somewhere here. 3, 5. Okay, so here 3, 5. B 3, 5. All right, children. So this is the meaning. I'm just showing you the Cartesian plane. This is the first quadrant. And these 2 points A and B lie in the first quadrant. The points A and B, they lie in the first quadrant, 7, 1 and 3, 5. Now this is the join of A and B. This is the line segment AB. So you know how to construct a perpendicular bisector. With A and B as endpoints, you need to use a compass fitted with a pencil. So the radius should be more than half the length of the line segment AB. The radius should be more than half the length of the line segment AB. So with A and B as centers, what will you do? You'll cut arcs here, no? You'll cut arcs here and join. Okay, so okay, so like this. So this is the perpendicular bisector. This is the perpendicular bisector of the line segment AB. How do we? You don't have to do this graph work, children. I'm just telling you how it looks. You can visualize the, you can see the question here. When you plot it in the Cartesian plane, you can see the question. So 2 points A and B, line segment AB, perpendicular bisector. That means with more than half the length of the line segment AB and using A and B as endpoints, you must draw arcs, 4 arcs like this and join. That's the perpendicular bisector. That's a perpendicular bisector. You know, it will make a right angle and this length is equal to this length. Perpendicular bisector. Okay. So now what is the question? You need to find the equation. Okay, we need to find the equation of this one. Also find its point of intersection with the x-axis and y-axis. So yeah, see here the perpendicular bisector, it cuts the x-axis here and the y-axis here. You need to find the coordinates of these 2 points also. You can see here from this rough diagram that the perpendicular bisector is a line. It's not a line segment, it's a line. So it will intersect so you can see here, in this case, it intersects the x-axis and the y-axis. Also find its point of intersection. That means the coordinates you must find. You must find the coordinates of the point of intersection of the perpendicular bisector with the x-axis and with the y-axis. So what's the address of this point? What's the address of this point? So these are the 3 things you'll have to answer. First is you'll have to, get that equation of the perpendicular bisector. And then the perpendicular bisector, it intersects the x-axis and y-axis. What is the address of the point where it meets the y-axis or where it intersects the x-axis and the y-axis? So these are the questions we need to answer. So for this, we use a property of the perpendicular bisector. I'll just take it like this now, children. Okay, AB, I'll just take it like this now. This is the perpendicular bisector. Now, let me take any point on the perpendicular bisector. Let me take any point on the perpendicular bisector, anywhere, any point. So like say here, I take a point P. That point P is not given in the question. We are taking a point P on the perpendicular bisector. And let's just join. Okay, we'll just join like this because we don't know how to find the equation of the perpendicular bisector. We need some condition. If this is equal to this, some condition we need, like you need a formula. If you're asked to find the area of a triangle, you will use the formula half base into height. And in the question, you should be given the base and height of the triangle. Similarly, how do we do this? No formula. So you'll have to create some condition. How will you suddenly find the equation of the perpendicular bisector? So some condition you need to work. Like when it is equidistant, we said PA is equal to PB. You need some equation. So if you can get some equation, then you can just work with that equation. So what we do is, I'll come again. This is the line segment AB. This is the line segment AB. Okay, this is its perpendicular bisector. Now let's take any point on the perpendicular bisector, say P. Now let's join PA and PB. Let's join PA and PB. Now we can prove that these 2 triangles are congruent to each other. These 2, you don't have to do all that. Okay, so these 2 triangles are congruent to each other. Why? Because it's a perpendicular bisector, right angle. 90 degrees here, 90 degrees here. In this triangle, this is 90. In this triangle, this is 90. So right angle. And then this side, let me call it O. Let me just call this O. So AO is equal to BO. Why is AO is equal to BO? Why is AO equal to BO? because perpendicular bisector, right? So it bisects AB. So AO is equal to OB. So AO is equal to OB and PO is the common side. PO is the common side. So in triangle AOP and in triangle BOP, AO is equal to BO. AO of this triangle is equal to BO of this triangle because it's bisected. AB is bisected. And then 90 degrees we have in both the triangles. And PO is the common side. PO is the common side. So by SAS, not RHS, SAS, two sides included angle. By SAS congruence criterion, the two triangles are congruent to each other. Side angle side, two sides and included angle. SAS congruence criterion, the two triangles are congruent to each other. So if the two triangles are congruent to each other, their corresponding sides and corresponding angles are also equal. CPCT. So now that the triangles are congruent, PA is equal to PB. See, how do you write congruency? Triangle AOP is congruent to triangle BOP. AOP is congruent to BOP. So you can see here, therefore AP is equal to BP, CPCT. AP is equal to BP, CPCT. So that is the condition. That is the condition. AP is equal to BP. AP is equal to BP is the condition. So what did I do? Line segment, perpendicular bisector. Take any point on the perpendicular bisector. Take any point. You can take it below also here. Any point on the perpendicular bisector. And join PA. That is, you're joining this point to the ends of the line segment. You're joining this point to the ends of the line segment. You're joining P to the end A, P to the end B. And you can straight away write PA is equal to PB. You don't have to work all this. And you know why PA is equal to PB, because these two triangles are congruent to each other. PA is equal to PB, CPCT. So that we say in words. Any point on the perpendicular bisector is equidistant from the ends of the line segment. Any point, this result, okay, this result, you can just write in words. Any point on the perpendicular bisector is equidistant from the ends of the line segment. See, what is this? PA is equal to PB, right? So A and B are the ends of the line segment. And P is any point on the perpendicular bisector. Any point on the perpendicular bisector is equidistant from the ends of the line segment. Is equidistant from, because PA is equal to PB. Any point on the perpendicular bisector is equidistant from the ends of the line segment. So that means PA is equal to PB. So this is what is the condition. You just work with this condition. If you know the condition, it's very easy. That's all. See it? So roughly I've just illustrated that. So you understand, children, I explained what it is. So let P, X, Y be any point of the perpendicular bisector L of the line segment AB. So we know that any point of the perpendicular bisector is equidistant from A and B. So that means PA is equal to PB or PA square is equal to PB square. So this is the condition. PA square is equal to PB square. So you can also write this, children. See, you don't have to write PA square is equal to PB square. You can just write this. And if you're writing PA, you should put the square root symbol is equal to PB, square root symbol. Next step, what will you do? Squaring on both the sides, squaring on both the sides. And you will get, the LHS and RHS without the square root. That we are doing it in the beginning itself, that's all. That we are doing it here. That squaring on both the sides, we are doing it here itself, that's all. If you're not comfortable with this, you can write this PA is equal to PB and proceed with that. What is PA? This is PA is equal to, this is PB. Then you can square, then you should square on both the sides. Next step, the square root will be eliminated. Oh. You don't have to write this PA square is equal to PB square, whatever is convenient for you. If you write this, don't put the square root symbol. If you write this, you should put the square root symbol and then square on both the sides. That's all. PA square is equal to PB square. Then you know how to write PA square. Using the points P and A. And then using the points P and B. So subtract the x coordinate, square it, plus subtract the y coordinate, square it. That's it. So I normally work it like this. I always bring, there's x here. So this x, I'll bring it to the LHS. and this is y. So I'll take this y to the RHS. So it becomes a difference of 2 squares. It becomes a difference of 2 squares. You can alternatively, expand using the formula as it is. That's your choice. So I normally, whenever possible, whenever suitable, I do this. So there's x here, there's x on the other side. So transpose. There's y here and there's y here. So transpose. So difference of 2 squares. So a plus b, a minus b on both the sides. Yeah. And then you simplify, and this is the equation. This is the equation. You can divide this equation by 2 throughout. You can divide this equation by 2 throughout. So you get x minus y minus 2 is equal to 0. X minus y minus 2 is equal to 0. So x minus y minus 2 is equal to 0 is the equation of the, see, you got a linear equation x and y. Because the perpendicular bisector is a straight line, and it's given by a linear equation x and y. So that's what you've got. X minus y minus 2 is equal to 0 is the equation of the perpendicular bisector of AB. Now you need to, find the point where it cuts the x-axis and y-axis. So we know that any point, so this is the line segment AB and this is the perpendicular bisector. So we need to find this point and this point. This is the line segment AB. You can make a rough sketch like this, children. It will be very useful for you to understand the question clearly. It will be very useful for you to understand the question clearly. You can plot that. So you can make the Cartesian plane, the rough column, make the Cartesian plane, and then plot the points roughly and take its perpendicular bisector. You can see that it will cut the x-axis and y-axis. So this address we have to find. How do you find this point? Well, we know that on the x-axis, the y coordinate is 0. So when y is 0, and you know that every point on the perpendicular bisector will satisfy the equation. Every point on the perpendicular bisector will satisfy the equation. So now this is a point on the perpendicular bisector. It is on the x-axis. Y is 0. So when y is 0. So in this equation, when y is 0, find the value of x. And then same equation, if the point lies on the y-axis, x is 0. So when x is 0, find the corresponding value of y. So when y is 0, x is 2. That means 2, 0, 2, 0. When x is 0, y is minus 2. That means 0, minus 2, 0, minus 2. So the perpendicular bisector meets the x-axis at 2, 0. Meets the x-axis at 2, 0, and the y-axis at 0, minus 2. At 0, minus 2. So to find the points where it cuts the x and y axis, when x-axis you need to take y is 0. For y-axis you need to take x is 0, because on the x-axis y is always 0, and on the y-axis x is always 0. So take 0, find the corresponding values of x and y, and you can make the points. Understood, children? Say yes or no.
Yes, ma'am. Yes, ma'am.
All right, children. Yeah. Take a picture and make sure to complete this. So this side is equal to this side. Congruency, this side is equal to this side. Yeah, this is your homework, children. Take a screenshot. Similar question. Find the equation of the perpendicular bisector of AB. Find the point of intersection with the x and y axis. Homework. Please work this. Done? Okay.
Yes, ma'am.
Very good. Thank you. Yeah, we'll just wind up the session with this one. Find the value of x if the distance between the points A and B is 5 units. So the distance between, let's just illustrate that. So A, B, we have, this is x comma minus 1, and this is 3 comma 2. The distance meaning AB is 5 units. AB is 5 units. The distance between the points A and B is 5. So just draw a figure like this. And what is given? AB is equal to 5 is given. That's enough. How do you find AB? Square. You can even square this. You can write AB square is equal to 5 square. AB square is equal to 25. You can also do that. So if you write AB is equal to 5, how do you find AB? Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. How do you find the length of a line segment? Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So is equal to 5. Then square on both the sides. Very simple. It's given the distance is 5 units. Distance meaning AB is equal to 5. Write this. Then for AB, you should use a distance formula. Is equal to 5. That's a work and you'll get the value of x. Take a picture, children. You can see there. AB is 5 units. If you want, you can square, I said. AB square is equal to 25. So when you write AB square, you should not put the square root symbol. So that's why you don't see the square root here. See, I've not used the square root symbol because it's AB square. So the square root is eliminated. So it's a quadratic equation. Split the middle term and find the values of x. So x can be 7 or x can be minus 1. X can be 7 or x can be minus 1. That means the point A can be 7 comma minus 1. This x can be 7. So A can be 7 comma minus 1 or A can be minus 1 comma minus 1 because x can be 7 or minus 1. So A can be 7 comma minus 1 or minus 1 comma minus 1. So it's getting time for my next class, children. All right, children. So that's it for today's session. Thank you so much. We'll have the regular class tomorrow in the evening. And the compensation classes I have in mind, children. I've not forgotten. I can forget it only after I make the classes. So until then, it will be in my mind. So I did promise by the end of August I'll do it, but I was not able to do it. But I will do those 2 classes. All right. All right, children. We'll meet in the regular class tomorrow. Yeah. That's it for today's session, children. Thank you so much. You may leave the call. Please complete your classwork and do that homework sum also.
Thank you.
All right, children. Thank you.
Thank you, ma'am.
Thank you. Thank you.